Today we shall study about the article a special purpose on PN junction diodes in the chapter Semiconductor Diode. The figure is shown in A and the VI characteristic shown in B. Now, the statement is for Zener diode. It is a special purpose semiconductor diode named after its inventor C. Zener. It is designed to operate under reverse bias in back-down region and used as a voltage regulator. The symbol for Zener diode is shown in figure 1a. Zener diode is fabricated by heavily doping both P and N sides of the junction. Due to this, the depletion region formed is very thin, smaller than 10 to the power minus 6 meter. And the electric field of the junction is extremely high, minus 5 10 to the power 6 volt per meter. Even for a small reverse bias voltage of about 5 volt. The IV characteristics of a Zener diode is shown in figure 1b. It is seen that when the applied reverse bias voltage V reaches the breakdown voltage Vz of the Zener diode, there is a large change in the current. Note that after the breakdown voltage Vz, a large change in the current can be produced by almost insignificant change in the reverse bias voltage. In other words, Zener voltage remains constant, even though current through the Zener diode varies over a wide range. This property of the Zener diode is used for regulating supply voltages so that they are constant. Let us understand how reverse current suddenly increases at the breakdown voltage. We know that reverse current is due to the flow of electrons, minority carriers from P to N and holes from N to P. As the reverse bias voltage is increased, the electric field at the junction becomes significant. When the reverse bias voltage V over Vz, then the electric field strength is high enough to pull valence electron from the host atoms on the P side, which are accelerated to N side. These electrons account for high current observed at the breakdown. The emission of electrons from the host atom due to the high electric field is known as internal field emission or field emission. The electric field required for field emission is of the order of 10 to the power 6 volt per meter. Now, Zener diode as voltage regulator. The figure shown in as Zener diode is connected with the series resistance and a load resistance. The unregulated DC voltage filtered output of a rectifier is connected to the Zener diode. So a series resistance R is such that the Zener diode is reverse biased. If the input voltage increases, the current through RS and Zener diode also increases. Then this increases the voltage drop across RS without any change in the voltage across the Zener diode. This is because in the breakdown region, voltage remains constant even though the current through the Zener diode changes. Similarly, if the input voltage increases, the current through RS and Zener diode also decreases. The voltage drop across RS decreases without any change in the voltage across the Zener diode. Thus, any increase or decrease in the input voltage results in increase or decrease of the voltage drop across RS without any change in the voltage across the Zener diode. Thus, the Zener diode acts as a voltage regulator. We have to select the Zener diode according to the required output voltage and accordingly the series resistance Rs optoelectronic junction devices, we learn about semiconductor diodes in which carriers are generated by photons, photoexcitation. All these devices are called optoelectronic devices. We shall study the functioning of the following optoelectronic devices. Photodiodes used for detecting optical signal, photodetectors. Second, light emitting diode, which convert electrical energy into light. Photovoltaic devices which convert optical radiation into electricity, solar cells. Now, we study about photodiode. As shown in the figure, it is connected with a battery and battery resistance and a microammeter. Yes, photodiode is again a special purpose PN junction diode fabricated with a transparent window to allow light to fall on the diode. It is operated under reverse bias. When the photodiode is illuminated with light with energy H nu greater than the energy gap Eg of the semiconductor, the electron-hole pairs are generated due to the absorption of photons. The diode is fabricated such that the generation of each pair takes place in or near the depletion region of the diode. Due to the electric field of junction, electrons and holes are separated before they recombine. The direction of electric field is such electrons reach N side and holes reach P side. Electrons are electrons, E-L-E-C-T-R-O-N-S. Electrons. Electrons are collected on N side and holes are collected on P side, giving rise to E and EMF. When an external load is connected, current flows. The magnitude of the photocurrent depends on the intensity of incident light. Photocurrent is proportional to incident light intensity. This photodiode can be used as a photodetector to detect optical signals. Light emitting diode. Second, light emitting diode. It is a hybrid of PN junction which under forward bias emits spontaneous radiation. The diode is encapsulated with a transparent cover so that emitted light can come out. When the diode is forward biased, electrons are sent from N to P when they are minority carriers. Electrons are sent from N to P where they are minority carriers, and holes are sent from P to N where they are minority carriers. If the junction boundary are either side of the junction, excess minority carriers are there, which recombine with majority carriers near the junction. On recombination, the energy is released in the form of photons. Photons with energy equal to slightly less equal to slightly less than the band gap are emitted. When the forward current of the diode is small, the intensity of light emitted is small, As the forward current increases, intensity of light increases and reaches a maximum. Further increase in the forward current results in decrease of light intensity. Leads are biased such that the light emitting efficiency is maximum. The VI characteristic of a LED is similar to that of a SI junction diode, but the threshold voltages are much higher and slightly different for each other. The reverse breakdown voltages of LEDs are very low. The reverse breakdown voltage of LED are very low, typically around 5 volts. So care should be taken that high reverse voltages do not appear across them. LEDs that can emit red, yellow, orange, green and blue lights are commercially available. The semiconductor used for fabrication of visible LEDs must at least have band gap of 1.8 electron volt. The special range of visible light is from about 0.4 micrometer to 0.7 micrometer. It means from about 3 electron volt to 8 electron volt. The compound semiconductor gallium arsenide phosphide is used for making LEDs of different colors. GS0 Eg minus 1.9 electron volt, used for red LED. GS Eg minus 1.4 electron volt is used for making infrared LED. These LEDs find intensive use in remote controls, burglar alarm systems, optical communication, etc. LEDs have the following advantages over conventional incandescent low power lamps: low operational voltage and less power, fast action and no warm up time required. The bandwidth of emitted light is 10 seconds to 100 angstrom to 500 angstrom, or in other words, it is nearly monochromatic, long life and ruggedness, fast on-off switching capability.